Hi guys, and welcome to the video for multiplying rational expressions. So in this video, guys, we're going to continue our rational expressions unit. We're going to start multiplying rational expressions and simplifying them. This is required for pre-calc. That's why we're going to do this, is because we need this for simplifying trigonometric identities. You'll know you're successful when you can take two rational expressions together, multiply them, and reduce them. So, we have a three-step process for multiplying rational expressions. That process is factor, cancel, rewrite, okay? So I'm going to constantly reference FCR, factor, cancel, rewrite, factor, cancel, rewrite, factor, cancel, rewrite. So what does that mean? It means that you're going to factor both the numerators and the denominators of all fractions, okay? There's going to be multiple rational expressions, multiple fractions happening. You're going to completely reduce both the tops and the bottoms of each denominators. You're going to factor them. You're going to cancel anything out of the top and the bottom that they have in common. Remember to cancel something. Remember that they must be exactly the same. That's the same as 7.1. So I could cancel x plus 1 over x plus 1. But I couldn't cancel x plus 1 divided by x minus 1. Cannot do that. And then step 3 is you're going to rewrite the remaining factors. You do not need to actually multiply anything in the numerator or the denominator. So factor, cancel, rewrite. So multiplying rational expressions is kind of deceiving. You're only going to factor, you're going to cancel, and you're going to rewrite everything that you can. And it's just simplification of two rational expressions. So we're going to jump right in. On the side here, I have factor, cancel, rewrite. And we're just going to start off right away with two expressions here. And what I am going to do is factor each one step at a time. So I'm going to approach the top here. This one's factored. X minus 5, I can't factor that anymore. I am going to move over to the left side here. And I'm going to note that that has a GCF of 4. So I'm going to factor out the GCF of 4 from the top. So the fraction would be 4 times x plus 2. So if I were to redistribute, remultiply everything out, it would be equal to the original. The other fraction, x minus 5, is on the top, and there's nothing that I can do there, so I have simplified this one. And then I am going to work the bottom here. So what I am going to do is note that this would be the difference of two squares. If you need help with that, please visit the video in Unit 3. But what you have is x plus 5 times x minus 5. Because x times x is x squared, and negative 5 times positive 5 is negative 25. So that always factors like that. So that creates, so I'm going to take that, and it goes at the bottom of my fraction here. And then on the right side, the last part of the fraction, I have a GCF of 5. So both the 5x and the 10 have a 5 in common, so I will factor it out and be left with an x plus 2. So I'm going to just put parentheses around this to quote-unquote make it a nest. So what I can do now, and I'm going to switch my color here, is I can cancel stuff. So I can cancel this x plus 2 and this x plus 2 because I have the same on the top here and the same on the bottom here, exact copies of each other. And I have an x minus 5 and an x minus 5. So I can cancel all of those things. So I'm going to do that. And then what's left is what I'm going to rewrite. So on the top, the only thing that's left is this 4. So the top of my fraction becomes a 4. And on the bottom, I'm left with a 5 times x plus 5. And despite the fact that we were quote-unquote multiplying rational expressions, all I ever really did here was simplify them. And so my final multiplied rational expression is 4 divided by 5 times x plus 5. So let's do another. My words here got a little, I'm going to drag them up. So this one's nice and simple. On the top, I have x plus 5 and x plus 5, and then x minus 3 and x plus 7. There's nothing to rewrite or nothing to factor here. They're all factored already, so all I have to really do, so I can kind of skip this one. All I really need to do is cancel x plus 5 divided by x plus 5. So all that's left when I'm done with this is x minus 3 on the top divided by x plus 7. I don't like the way my fraction bar got curved. Divided by x plus 7. And that's it. It's as simple as that. So let's take a look when we have a polynomial times a rational expression. So when you come across a circumstance like this, what we need to do first is we need to put this over 1. So it's going to have a 1 on the bottom. So essentially, what I'm going to be factoring is I'm going to try to factor the top here. 1 is already factored, x is already factored, and then I'm going to have to factor this. So I have 2 parts that I need to factor, so I'm going to look for the GCF of this. The GCF of the top expression, since there's only 2 terms, is an x. So I can factor an x out. So if I rewrite my fractions down here, I get x, and then what's left over is x minus 2. On the top of the other fraction, we know that x is simplified. On the bottom of this one, we have a 1. So now I need to factor this one, and I'm going to do so using the diamond, or the umbrella star method. 1 times 6 is 6 on the top. And then we have a negative 5 down below. An x, an x. Remembering that when we have a negative down below and we have a positive on the top, we have double negative factors. So the 2 factors that would add or combine to negative 5 but multiply to positive 6 would be negative 2 and negative 3. So we would put x minus 2 here. And we would put x minus 3 as our 2 factors. So now what I can do is I can go ahead and I can go through and I have an x minus 2 here and I have an x minus 2 here. I am not allowed to cancel the x and the x because they're both on the top. So on the top, when I rewrite it, oh, I forgot to switch to black. Switching back to black here really quick. I got an x times x. And on the bottom, I have 1 times x minus 3, which is just x minus 3. So I'm going to then just do some combining of like terms. X times x on the top is x squared divided by, on the bottom is x minus 3. And there is my completed multiplied rational expression. Okay, whew, this one is a doozy. If you take a look at this one, it has multiple expressions that all have to be factored. So let's start with the upper left-hand corner. I realize that none of these x squared, negative 3x, and negative 4 have nothing in common. So there's nothing that I can GCF out. So I'm going to need to trinomial factor. I'm going to have to trifactor it. And I'm going to have to trifactor pretty much all of these. So if I'm really looking at this, I'm going to need to trifactor this and this as well. And this one, I recognize. I know that it's going to be difference of two squares. So difference of squares. So let's go ahead and put our big multiplication sign down there. We're going to have a fraction bar and a fraction bar. So the one on the upper right-hand corner, I'm going to start with the difference of two squares. I know 4 is the equivalent of 2 squared. So that gives me the two factors, x plus 2 and x minus 2. Okay, so that knocks out the upper right-hand corner. And it doesn't matter what order you do any of these in. All you have to do is just make sure that you factor each and every one, and make sure you do it separately, and make sure that you do it in a manner that you can keep track of. So for the upper left-hand one, I'm going to label this with a 1. So that way these stars don't get mixed up. I'm going to have negative 4 on the top, an x here, an x here, and a negative 3 down below. So because it is a negative 4, I'm going to have a positive factor, and I'm going to have a negative factor. And because the number on the bottom is a negative number, it implies to me that the number on the negative side is going to be larger. So I'm going to think about the factors of 4 as 2 and 2. 2 and 2 would be 0. That's not going to work. If I did 1 and negative 4, I would get negative 4 on the top and negative 3 on the bottom. So those are the two factors. We'll have x plus 1 times x minus 4. Okay. So those are the tops and the bottoms, two tops factored. So we're going to start with the left denominator. So that is number 2. And so number 2, that star, we'll be putting a negative 2 on the top. We'll be putting a negative 1 on the bottom, x and x. One of these is positive and one of these is negative. Well, the only factors of 2 are going to be 1 and 2. And they have to be combined in this way, so that because you do positive 1 take away 2 is negative 1. So the bottom left factors as x plus 1 times x minus 2. And you can probably already see some things that are going to cancel, but we're going to just finish off all of the factoring first. So then number 3, the third trinomial that we have to factor, has a negative 20 on the top, and it has a positive 1 on the bottom. So x and x, because again we have to have a positive and a negative factor. This time the positive factor needs to be larger because it is a positive number down below. Factors of 20, you've got 1 and 20. That's not going to work because it's going to be 19. You've got 2 and 10. That won't work because you're going to get 8. And you have 4 and 5. So if we do 5 and 4, we get 5 minus 4 is positive 1. So then we can do x plus 5 here and x minus 4. So again, you can probably see some things that are going to cancel already. I'm going to go ahead and switch my pen to red. And then I'm going to go ahead and start looking for stuff that I can cancel. So I can definitely cancel this x plus 1 over this x plus 1. This x minus 4 can cancel with this x plus 4 nest over here. And then this x minus 2 can cancel with this x minus 2 over here. So now I just rewrite everything that's left over, and all that I have left over, oh, I forgot to switch my pen to black again. Switch my pen back to black. All that's left over is x plus 2 in the numerators, and in the denominators, x plus 5. And there is my rational expression multiplied out. So, last one. This one is going to take a little bit of time, especially considering the fact that we've got some factors that are greater than 1 out front. But I need to make sure that I show you how to do this kind of problem in case you see it again. So each one of these is going to be factored the same way. So we've got 1, 2, 3, and 4. So I'm going to just start factoring. I'm going to need all the space that I can. So 1 here. I've got a 2. I'm going to multiply the 2 times the negative 6 is negative 12. And then a 1 down below. Put a 2x here and a 2x here. And then let's think of the factors of 12. One of them has to be positive and one of them has to be negative. 2 times 6 would be positive, negative would be 4 or a negative 4. That's not going to work. If we did positive 4 and negative 3, that'll work. So if we look at this, 2 over 4 could be reduced to 1/2, but 2/3 can't be reduced. So the first set of factors, I'm going to draw out my fraction bars here. The first set of factors, this over here, the 2x over 4, this would reduce to x over 2, 1x over 2. So the first factor is x plus 2 times, the other one would be 2x minus 3. Okay, so that is the first one factored. And then we're going to do number 2. So factor it out. X or 1 times 12 is 12. Negative 7. X and x. So remember, a positive on the top and negative on the bottom means both the factors are negative. So the factors that I can think of that are multiplied to 12 but add to negative 7 would be negative 4 and negative 3. So we've got our two factors, x minus 4 times x minus 3. And then we're going to do number 3. Factor number 3. 3 times negative 3 is negative 9. And then negative 8 goes down below. We're going to put a negative 3x here and a negative 3x here. So let's think of factors of 9 that add up to 8. One of them has to be positive and one of them has to be negative. If I look at the factors of negative 9, the only ones I have are 1, 3, and 9. 3 and 3 would cancel out. So it's got to be 1 and 9. So it's got to be positive 1, negative 9. This side, the negative 3 over positive 1 can't be simplified. But I can cancel out a 3 on both the top and the bottom of 3 over 9. So I'm going to get x over negative 3. So my two factors are going to be 3x plus 1 times x minus 3. And you can probably start to see some of the things that are going to cancel out. And so then the last factoring I'm going to do is over here. 2 times negative 4 is negative 8. And then negative 7 goes down below. So 2x and 2x. So the factors of -8, one of them has to be positive, one of them has to be negative. Factors of 8 would be 1, 2, 4, and 8. 2 and 4 would combine to be either -2 or +2. And then if I did 1 and 8, I will get -7. So then 2x plus 1 cannot be simplified. So 2x plus 1 cannot be simplified. But I can simplify this one here to be x over -4 because I can take out a 2 from the top and the bottom. So it'd be x minus 4. And now that I have factored everything, I can take my red pen and I can say, okay, I have a x plus 2 here, and on the bottom I don't have any x plus 2's, so we're going to move on. 2x minus 3. There's no 2x minus 3's anywhere. X minus 4, I have one here and I have one here. And then I have an x minus 3 and an x minus 3 over here. And now that I have done all of my canceling, I don't need to rewrite anything or remultiply anything. I'm going to have x plus 2 in a nest, in a parentheses, times 2x minus 3. And then on the bottom of my fraction, I'm going to have 3x plus 1 times 2x plus 1. And that's it. That's rewritten, multiplied, rewritten after combining everything. So I have factor, canceled, and rewrite. So that one was a long, complicated one, guys, mainly because of so much factoring. But I had to show you the most complicated that it's going to get. So remember that you need to follow the steps in order to multiply rational expressions. And that order is always factor, cancel, rewrite. FCR. If you are struggling with the factoring, brush up on your factoring skills by going back and watching the basic factoring videos from Unit 3. Take a look at some examples from GCF factoring. Take a look at the trinomial factoring. Trinomial for a equals 1. And then also look at a is greater than 1. And that's it for today's video, guys. I know that it was a long one. Thanks for sticking with me. Thanks for watching. And I'll see you in the next one.